So, how exactly is an ask from your friend for lemon lavender pound cake related to data structures and algorithms? Listen in because I walk through exactly that. Hey y'all, this is Juelle, and you are listening to the Ingredients and Methods podcast, where we go through a few of my favorite things cooking, baking, music, and technology, and look at the ingredients and key methods behind those things, as well as how we can all add our unique creative flair and create art out of them. Stay tuned, it's going to be fun, and we're going to learn a lot together. Alrighty, hello. Let's talk about data structures and algorithms. So, in this episode, I'll take you through what are data structures and algorithms. Then we'll think about applying them for a cake, right? Because I love baking, I love cooking, and I love technology. So let's merge them in this example. Then we'll translate that example to a few data structures and algorithms to really get it in the terms of the computer science versions that you use for problem solving. And last but not least, we'll bring the pound cake recipe back around and I'll show you how you can apply these frameworks and using additional context, clarifying questions, and so on, really come up with a solution. So, to get things started, let's answer the question, what are data structures and algorithms? So, the way I describe them as they're the foundation, building blocks, and frameworks applied in the development of software solutions. Now, this is really specific to being software solutions. You can go a level up and say technology solutions, and you can even really go a level above that and say solutions in general, because they really help you to put a problem into perspective and then using any unique aspects of a problem or a challenge, then you can really start to build an efficient solution. So to really help to break this down, I thought it'd be cool to think about someone like a friend or a family member asking you to bake them some pound cake, bake some pound cake for them. So let's say your friend asks you to bake them a lavender lemon pound cake. Now, the key ingredients to pound cake are butter, sugar, eggs, and flour. And with this being an ask for a lavender lemon pound cake, there's going to be a need for some lavender element and a lemon element as well. And, of course, you can go above and beyond that. You could add a pinch of salt, you can add some baking powder and different things. But really, at the core, you need butter, sugar, eggs, and flour, a lavender element, and a lemon element to get those flavors in there. Now, thinking about the approaches here. So, how can you make this lavender lemon pound cake? I have four examples, four potential methods. The first one is, you could bake a regular pound cake and then make a lavender lemon icing, then put that icing on top of the cake. And technically, it is lavender lemon pound cake, right? You could also add some lemon zest to the pound cake batter directly and add a lavender icing on top of the pound cake. So the lemon flavor is in the cake batter. And then when you bake the cake, you can top it with the lavender icing. Then you get your two flavor profiles. You could do the reverse of that by grinding up some lavender flowers and adding that to the pound cake batter, then topping it with lemon icing. So the lavender flavor is inside of the baked cake and the lemon flavor is on top as an icing. And a fourth option is you could add both into the pound cake batter directly. So the lemon zest and ground up dried lavender flowers, bake the cake and serve it as is with no icing because you've covered ground with the flavors by putting them directly into the cake batter. And these are all valid options. I mean, at the end of the day, you're gonna get lavender lemon pound cake in some form. The way that you really go about deciding which method you'll take involves thinking about trade-offs and thinking about maybe the specifics of the ask, and maybe working with your friend or family member and saying, what kind of cake do you like? Do you like icing? Do you not like icing? How will the cake be transported? Is this someone that lives with you in your home so you can just, put it on a serving platter and that's that? Or is it someone who maybe you're going to ship this cake to them, or do you need to drive it to them? When do they need the cake? So are they saying like, oh yeah, sometime soon I'd like some pound cake? Or are they saying like, hey, I have a birthday party coming up in a week, and it'd be really cool if you could bake me some of your famous lavender lemon pound cake. Also think about the tools that you need. So are you tight on space in your kitchen and where you're baking the cake to where it might be easier for you to just whip up a cake really quickly, clean up the space because you're tight on space, and then make the icing while the cake's in the oven? Or do you have space where you can spread out, grind lavender flowers, zest a lemon, and so on, and then mix everything at once? Are you sharing the oven with anyone? Like what kind of access to tools do you have? And also the desired intensity of the flavor. So do you want it to be strong in lavender with a hint of lemon? Do you want it to be strong with lemon with a hint of lavender? Do you want them to be balanced flavor wise? Um, those are also, you know, these are all inputs into how you really go about baking this cake. Now, let's work on translating that into computer science concepts and really thinking about the fact that data structures and algorithms represent the tools and the frameworks and the approaches, the building blocks, the foundation of solving problems when you really get down to it. So looking back at this ask, right? So you can say the ask for the lavender lemon pound cake is your problem statement. Your friend or family member brought this to you. The key ingredients, butter, sugar, eggs, flour, lavender, and lemon elements, are the data structures and the data, so the actual inputs, right? Along with the other details that they would give you, like timing and preferences. This is how you would really structure what you're going to do next. Like you need these items, and then you're going to do something to them with a specific approach, and it's going to produce the lavender lemon pound cake that is the best one for you and your friend. And speaking of those approaches, when you get down to the potential methods that we discussed, the four that we thought of, and there are more, those are where algorithms and approaches come in. So, really, what do you do with the inputs of the data and the data structures? And thinking of their limitations. So, maybe with lemon, instead of lemon zest, maybe you want to do dried lemon powder because this is a request that you get on a regular basis and you want to be able to quickly whip up lavender lemon pound cake. So you don't want to have to always have fresh lemons on hand. That's going to that change in the input, the data is going to affect your approach, right? Because then maybe it's easier for you to whip up icing. So breaking that down again, the ask is your problem statement, the inputs, which in the framework of a cake is the ingredients and the specifics of what your friend really wants. And the algorithms and approaches are the I think I skipped saying data and data structure. So going back, the ask is the problem statement, the key ingredients are the data and the data structure, the key ingredients and the specifics, because I feel like it's really important to mention that while you have key ingredients, there's a concept of having an edge case, which is sort of testing the boundaries of your data and your inputs and your approaches. And in this case, it might be that your friend really likes icing or your friend really does not like icing. And then last but not least, the potential methods, so the algorithms and the approaches. So speaking of those trade-offs in the world of data structures and algorithms, there's the concept of space and time complexity. So how long does your approach take based on the data and the data structures? Does it take a longer amount of time for you to bake everything into the cake, given fresh lavender flowers, maybe that you have to dry them yourself, or if you buy dried lavender flowers, does that make things faster or slower? And how much time do you have? Does it matter how much time it takes? And then when it comes to space, there's also um, in computer science, it's really thinking about the space, the computing space that you need to process your program, your function, whatever the case may be. When it comes to pound cake, the space for you might be literal space, um, because you're gonna need to store the data. So you're gonna need to store the butter, sugar, flour, and eggs because maybe you're a cake baker and you get requests all the time. So you have space, and storing dried lavender flowers and fresh lemons, or having a lavender plant is no issue for you. But maybe it's something where you can't have them on hand all the time because space is an issue, so you need to be able to access them in real time. So that's something to consider. And there are other trade-offs that go into data structures and algorithms as well, um, that kind of like play into how you develop your final solution. So, with that kind of semi abstract example of baking a pound cake for your friend, let's look at some actual examples of data structures and algorithms. So, for data structures, we'll look at three, and for algorithms, we'll look at two. And then we'll see how they kind of map to each other. Data structures, the three that we'll go into today are trees, stacks, and queues. So, trees at a very high level are basically multi level data structures that hold data in these things called nodes. And the nodes have children. A special kind of tree is a binary tree where you basically specify that any single node can only have two children. And basically, what a child is if you imagine a branch, and at the top of the branch is a leaf, and then coming down from the branch, there can only be two, or another child would be like, let's say there's another leaf on that branch. So a binary tree is saying that you can only have two leaves per branch that has one leaf at the top. And then the branches can continue to extend out from below that. But each section of the branch that starts with one leaf can only have two leaves coming down. That's one example. And there are various ways to search for data in a data structure like this, to move data in a data structure like this, and to really manage data. The second one, the second data structure is stacks. So imagine literally a stack of pancakes. Like, I remember in one of my classes, in one of my computer science classes, I think this was the example. Like, or maybe it was at that time I was like looking into additional study, and like I thought of this example. But you could think of a stack of pancakes or a stack of plates even. And when you stack your plates and pancakes, the first pancake that you put down is at the bottom, and then you add more pancakes on top as you continue cooking them on your griddle, you're making breakfast. And so when you start serving your pancakes, usually you don't like take the stack of pancakes and like flip it over and then you serve like the first pancake that you made. You usually leave the stack of pancakes as is, and then you serve your pancakes from the top going down. So this concept applies to the data structure of stacks. Stacks is we use this term LIFO, or LIFO, last in, first out, because the last pancake that you put on the stack is the first one that you're going to serve. Sort of the opposite of that, a related data structure would be the data structure of queues. So queues, I remember this analogy in my head. Like I have like it's really helpful for me to think about these concepts and like see visual examples. Like I literally see a stack of pancakes. For queues, in the US, a lot of times we'll say like, "Oh, you're standing in line." In other parts of the world, you'll say there's a queue. So it's kind of like that. Like as you get in line, as you get in a queue, let's say that you're at the DMV doing something related to your car, maybe your registration or something like that. And oh wait, I guess you don't go to the DMV to register your car. Okay, let's say you're in line to see like your favorite DJ. And the first person that gets in line is usually the first person that gets into the venue, right? So that's similar. That's like how you can think of queue. The first data point that you put in is the first data point that comes out, first in, first out. So FIFO. So remember, stacks, you're stacking your pancakes as you cook them. And then when you serve them, the one that's on top, so the last pancake that you cooked is the first one you'll serve. Last in, first out, standing in line to see your favorite DJ in New York City. If you get in line, you're the first person in line, you'll be the first person in the venue. So, first in, first out. Now, algorithms, I like to think of algorithms as the methods. The idea for this podcast really came from the way I see things as being ingredients, and then you do something to those ingredients, you do something to the inputs, and those are called methods. So for me, I say data and data structures are really ingredients, and then algorithms are what you do to those ingredients. What's the method? How do you handle the data and the data structure? So two that we'll look at would be breadth first search. So going across the breadth of your data structure. In this case, we can think of a tree that has many nodes, many branches, and depth first search. So going kind of like down one route, one path of your tree to find a data element, and then continuing going down before, and then eventually you'll make it across the entire data structure. So now mapping them to each other, breadth first search is a way to travel through a tree. And when you say travel, you can say traverse, and you can also say search. A queue is what the breadth first search algorithm uses to in implementation. So remember, a queue is first in, first out. So you're going kind of, you can imagine left to right. It Left to right may not be the most comprehensive description of breadth first search, but let's just say, right, that we have um, like a four level tree, and we're going to go left to right and just see if the number 14 is in the data element 14 is in our tree. We'll go left to right. If it's not on level one is our root, so there can only be one root. Then we'll go down to the second level. If 14 isn't there, we'll go down to the third level. Let's say we found it there, then we found what we were looking for. Depth first search is another way to travel, traverse, search through the tree data structure. And there are actually implementing three ways to implement depth first search. So there's in order search, there's pre order search, and there's post order search. And they all represent different ways that you can find an element. Um, I think they really do matter if, let's say that instead of looking for the number 14, you're saying print every time you see a number that ends with the ones digit being four. Then the way that you and let's say you want to go depth first search, then it actually does matter which type of depth first search you choose because the way that's going to be printed out will be affected. And depth first search uses the stack data structure in its implementation. So remember, the stack data structure is like a stack of pancakes or a stack of plates where the last element that goes into this data structure is the first one that kind of pops off. And um, when we talk about stacks and queues, one thing I do want to mention is the terminology of adding and removing elements from these data structures. So for a queue, when you're adding something, you would say we're in queuing the queue. So you're adding something. When you're removing, you'll say we're dequeuing the queue. We're dequeuing some data. For a stack, you're pushing when you're adding something. So you push that pancake onto the other pancake. You push the plate, especially like thinking about, um, all you can eat restaurants. Sometimes those plates are kind of like on springs. So like when they bring out clean plates, they'll push new ones on top. And when you remove a data element from a stack, you're popping the data element. You're popping it off. So you're taking it off. So I hope that introduction, these are really kind of like a high level, brief introduction. If this is something that really interests you, I really encourage you to look more into the details, like check on what I said, try to think of examples in your own world that can help the concepts um, become as clear as possible to you. And, if you're not already considering a career in technology, maybe like see if that's something that you want, if it's something that will help you in the career that you're in right now, even. But I think it's really, really cool. And even if you don't end up being directly in a technical role per se or an engineering role per se. Like we solve problems every day, just like living. And I find that having some sort of framework by which you start with to solve problems is just like really helpful. So this kind of thinking helps you to stay sharp in that way, in my opinion. Um, Before I wrap up, I do want to go back to the pound cake example and really talk about those kind of specifics that come up with problem solving, right? Because a lot of times we are faced with interesting challenges or new challenges, new problems to solve. And a lot of times they can seem really familiar. You might be like, oh, yeah, like last Thursday, my aunt asked me to bake a lavender lemon pound cake. Like, I'll just do the same thing. And sometimes that works. Like sometimes like the same cake you bake for your aunt is like the same cake you can bake for your friend. Sometimes it doesn't work though. And sometimes you need to think about the framework that you have, the data structures, the algorithm, the approach, and everything, and think of the special unique case. So thinking back to this ask, let's say that your friend said, oh, actually, sorry, this is kind of like a last minute ask. Could you have it by tomorrow? Like let's say like your friend really had like asked another cake baker and for some reason they couldn't come through, and they're asking you and they're saying, hey, like there's actually this event tomorrow and the cake would be great, and you're going to the event, so you could just bring it, you could take it with you, and the event is across town, and from your experience you know that the best way to take the cake is to wrap it in some foil. So knowing all of this, you're kind of on a time crunch. You might not have enough time to really plan out a super pretty glaze. You know that you're wrapping the cake in foil. It needs to be transported across town, and you've been on a time crunch. You have your own stuff to do, but you also want to help out your friend. So you might go with the fourth method that we discussed earlier, where you just add the lemon zest and the ground up dried lavender flowers directly to the pound cake batter, and you serve the cake as is with no icing. This helps you think about the trade-off of time because the ask is kind of last minute, but you still want it to be a really good cake and you still want your friend to enjoy the cake. And it also helps you to take into consideration how the cake will be transported because you don't want to ice a nice cake knowing that you're going to wrap it in foil and drive across town with it only to unwrap it and have a really messy deliverable. So taking into consideration those trade-offs, you decide to go the route. You make the cake, it's a hit, and now people are asking you for your recipe, asking you to bake them more cakes, and it's all good. And you were able to have this success because you took your appropriate data and your appropriate input. You thought about the relevant approaches and the what relevant ways you could make this cake. And then you also thought about the additional context that your friend needs it in a day and they need it in a location that's kind of across town. You need to wrap it in foil to transport it properly. And you use those as additional inputs to make the best cake that you could for your friend. I hope this was really fun for you. I hope you learned something new and can start thinking in the framework of inputs and methods, ingredients and methods. And yeah, definitely. Thank you so much for listening. This was really fun for me to put together. I really learn and get sharper with concepts when I'm able to teach others. And so let me know if this is the kind of content that you enjoy hearing and the approach I took, kind of like mapping two seemingly different topics together. And if there are other concepts that you'd like me to dive into, let me know that too. Until then, thanks so much for listening, and I connect with you soon.